Welcome to Lab Report 1 as I apply Newton's second law to constant velocity motion. I want to start with an analysis of the mathematics that we're going to use. I want to begin with this expression of Newton's second law that we see quite often in textbooks. I want to expand acceleration here. To start, this is force equals mass times acceleration. And acceleration is a change in velocity over time, so I simply expanded that. What I'm doing next is dividing both sides by m. I want to apply some further algebra and multiply both sides by delta t. And then the next move I'm going to make, I'm going to add the initial velocity to both sides. So I get initial velocity plus force divided by mass times delta t equals the final velocity. And we might note that this is a valid mathematical expression, but it's not a good assignment statement to use in our code. So I'm simply going to rearrange it, where final velocity equals initial velocity plus force divided by mass times delta t. This is a valid mathematical expression as well as a good assignment statement that we can use in our code. Now, in addition to needing final velocity information, we're going to need position data, and I want to use this expression in our code, where the final position of our object is going to be equal to the initial position plus the final velocity obtained from this expression times the change in time over which we apply this. Moving into our tracker data, I used a constant velocity cart in the high school physics lab, and we ran this cart from right to left. I decided to put the origin in the middle of the cart for no particular reason. And then as we run the cart, we can see how we chose the data points there and got a nice negative slope to our graph. We were asked to discuss our axes. Now, I just put the axis here because it was convenient. I could have moved the axis to the other side. We still would have had a negative slope because our object's moving from right to left. If I had run the cart the other way, the slope would have been positive regardless of where I put the origin. Where I put the origin simply will give us information about whether our position data is positive or negative. I used a ruler to measure the length of the cart, and that's how I came up with the distance information that's needed in Tracker. Now, moving into the code, get this out of the way. I want to talk briefly about the coding decisions that were made in the course of running this software. The mass of the cart was 0.62 kilograms, measured on a triple beam balance. The initial ball position was taken from Tracker. This initial velocity of the cart of negative 0.45 meters per second was obtained with position and time data from the first data points in Tracker and calculated with a change in position over time. We chose to use the t starts at 0 because that again matches the Tracker data that we gathered. I chose 1/100th of a second for delta t because that's a sufficiently small amount of time for the situation that we're observing. I applied Newton's second law in a loop for 2.2 seconds, again because that's the length of time in the Tracker video. Now, these expressions of ball velocity and ball position are the same expressions that we found and derived earlier. So we might note that that's where those formulas came from. The force vector was set to 0 because this is constant velocity motion over 0 net force. Now, we can't say that there were no forces acting on the object. We're only saying here that the net force equals 0. The combination of forces on our object are equal to 0. Now, to very quickly run our software, we can see that we got a motion to the left and a negative slope, and this agrees with the motion of our actual object. If we look at our graph data here and see what happens, the actual model position in red and the experimental position agree slightly. The error in this came from the original position and time data. The original slope that was calculated over those 0.04 of a second give us the error that magnifies throughout the lab. So to increase the accuracy of our model, I would need to be much more careful in gathering that original data in Tracker. And I see that I'm close on time, so this concludes my lab report. Thanks for listening.